Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 7, Lesson 9, on logarithm rules and solving. Okay, so there are a lot of logarithm rules, but I put the main 9 that there are. But also, I need to say one thing. Logarithm of negative... Okay, I did that thing again, where I accidentally created a page. Negative... well, we can just say x. Anything that's negative equals extraneous. Also, pretty much just undefined. So that's one rule to keep in mind. But we have 9 questions here, and they correlate with the 9 rules, luckily. So at least you know that. So these look really crazy, so I'll try to explain what they mean. 1 and 2 we've already gone over. So we know that basically what 1 and 2 are saying is that if you need to change into this form or this form, that's how you do it. That's basically what it's saying. It's a how-to rules, kind of. So we see A, B, and C. We change them to A, B, and C there. So keep in mind, my undo button is lagging, so I can't really use it right now, so sorry about that. And same thing with A and B here. That's how you can do that. Right? What do these mean? Well, these 3 through 5 are just true statements, basically. The logarithm of 10 equals 1. The natural logarithm of e equals 1. Remember, e equals 2.718281828, etc. Remember. Well, actually, don't remember. I mean, that's not something you have to memorize, just like pi, but I guess it's kind of useful to know. It kind of is easy to remember if you just know that there's a whole bunch of 8s and stuff, but... And then the logarithm of 1 is 0, so those are 3 rules you need to know. 6 through 9 are just operational rules. For 6, if you have 2 things that are equal to each other, in which there's 2 bases... If they're equal, then the 2 operations that we have are equal to each other. Not operations necessarily, the 2 values we have in those places are equal to each other. 7 says that basically you can just rearrange these values. That's kind of like what 1 and 2 are like. C can be an exponent of x, but it also can just multiply by log. 8 and 9 say that if you add or subtract 2 logarithm expressions, then when you add them, you multiply the values, but if you subtract them, you divide the values. So that's what those mean. And let's practice these rules. So we need to rewrite log of base of x, log base of x of y equals z into exponential form. So remember, we can have these values as a, b, and c, and using that rule 1, we know that a to the c power equals b. So a is x, c is z, b is y. That's how you could rewrite that. Alright, now let's look at 2. Rewrite log base 4 of w into change of base form. Change of base form is what 2 is. Basically, it's the thing that you can do to make it go into the calculator, which is this. So, in this case, 4 is a, b is w. So, to do that, we need to say logarithm of w over logarithm of 4. Of course, to type that into the calculator, you would need to know what w is before you can do that. Or you could just graph that. Alright. X says, or 3 says, find x. Well, we know if the logarithm of something equals 1, this is just a rule. You can't really solve anything, but you can just know that x equals 10. ln of x equals 1. Well, that's again going to that rule that x would have to be e. Which, remember, e is something like pi. It's not another variable, or that wouldn't even make sense. We could really say x equals 2.71 approximately, but we can just say e because that's the formal value for that value. So e. And by the way, there is a e button on your calculator. There should be, just like there's a pi button. 5 says log of what equals 0. Anything that equals 0, we know that would have to be 1. Alright? Now, it's saying find d. Okay? Well, since we see that these are equal to each other, that goes back to that rule that the things in parentheses, or the values, have to be equal to each other. So therefore, d must be 12. Alright? For 7, we need to find d again. This is the rule saying that the exponent of x is the same as something that can be multiplied by d. What's the exponent of x? 5. What's being multiplied by log? D. So d is 5. They're the same thing. You could write that either way. You could change the 5 to d, or change the d to 5, and then they would be exactly the same. Find q. Alright, so we're adding these two things together. Technically, you could go into the calculator and do that, but then you would get some crazy number, and you need to find just what q is. So, this is going to the rule that if you add two logarithm expressions, the values in the parentheses can be multiplied. So, since we have the values of 7 and 8, they can be multiplied to get 56. That's what q is. Alright, find r. And this, I know for a fact, is meant to be a minus sign, sorry. This is the rule that if you're subtracting two logarithm expressions, you need to divide the two values in here. So, we need to do 519 divided by 173, which is 3. Obviously, you probably don't know that off the top of your head. It's just a common one I remember. But r is 3. So those are how you can use different logarithm expressions. And that's it for this video, and I'll see you on the next one on exponential word problems.